This is R.D. Sharma solution. We are taking class 12, chapter 19. Exercise is 19.32, indefinite integrals. Now in this exercise, the main process or the starting point is to get rid of the root. So when we eliminate the root, then we can simplify the integration. Then we will apply the normal formula, like integration of 1 by x square plus a square, integration of 1 by x square minus a square, like that. So this is your integral. X plus 2, that is under root x plus 2, can be taken as some t, p or q. Or you can say that x plus 2 can be taken as t square. T equals to under root x plus 2. That simply means t square equals to x plus 2. Then you differentiate it. So when you differentiate it with respect to x, on the right, nothing will come. On the left, it will be 2t dt by dx. That is, if we want dx, that will be equivalent to 2t dt. So this integration will be formed like this. So take this x plus 2 as t square, under root t square will be t only. Now x minus 1 has to be changed in terms of what we have assumed. So dx becomes 2t dt. Under root x plus 2 becomes t. Now x minus 1 be written in this form also. What is x here? If you take this 2 on the left, x is equivalent to t square minus 2. And you have to write x minus 1, so that you have to add a negative 1. So this becomes t square minus 3. So let's write t square minus 3 here. Now tt gets cancelled. This dt integration, this t square minus 3 can be written as under root 3 whole square. That means integration of dx divided by x square minus a square has a direct result which we have proved also. 1 by 2a log x minus a divided by x plus a. Everything inside log will be inside a modulus sign. A will take as root 3. So 1 by 2a, 1 by 2 root 3 log, what is x here? T. T minus root 3 divided by t plus root 3 plus a constant of integration. Now t was initially taken as what? It was under root x plus 2. Now this replacement will do in order to write the final answer. So 1 by 2 root 3 log remains like this. T will become under root x plus 2 minus root 3 divided by under root x plus 2 plus root 3 plus a constant of integration. This is your final result. So this is the solution or reference, you can say. Most of the question of this exercise are like this only. Same way the question number 2 also needs the same logic and same process to complete. So we need to get rid of this under root. So we have under root 2x plus 3, and this 2x plus 3 can be equated to t square. So this under root t square, basically its total is your t, and we need an x also from here. Why? Because x minus 1 also has to be written in this form. So we will find out a separate x that will be put inside x minus 1 in order to get that value of for x minus 1. Next step will be the differentiation of this t square equals to 2x plus 3. So on the left, after differentiation with respect to x, 2 will come. On the right, it will be 2t dt by dx. 2 gets cancelled. So dx in this case becomes equivalent to t dt. Now whatever we have done, these three different things, we will combine them and put it here. Dx will be t dt, under root 2x plus 3 will be t only, and x minus 1, for that we need to subtract a 1 from here. So t square minus 3 divided by 2 minus 1. So this will be t square minus 3 minus 2 divided by 2. This becomes t square minus 5 divided by 2. So t square minus 5 remains in the denominator. 2 will go up. T gets cancelled. So we are integrating with the 2 outside. Dt divided by t square minus, now let's make it a perfect square, under root 5 whole square. So 1 by 2a, 2 also is there, log x minus a by x plus a. So t minus root 5 divided by t plus root 5 inside the modulus sign plus a constant of integration. So the final integration will become like this. In place of t, we will put the initial value which we assumed, and it's under root 2x plus 3. So 1 by under root 5 log modulus of under root 2x plus 3, here also under root 2x plus 3 minus root 5, and this is plus root 5 plus a constant of integration. This is your I. Now this is how you are going to go about it. So 2 questions we have done of the similar form, and this question also will take the same process and shape. And the whole idea about this exercise is to get away from this under root x plus 2 in order to replace other things in terms of under root x plus 2 if it is assumed to be some variable which you can call it as t, p or q, up to you. So this x plus 2 we have taken as t square, and you will get x from here, it will be t square minus 2. Now when you put t equals to under root x plus 2, or you can say t square is equal to x plus 2, you can differentiate it because we need to replace dx also in this terms. So 2t dt by dx will be equal to 1. So 2t dt will be equal to dx. This is the second replacement we'll do. Now we have to change this x plus 1 and x minus 1 also in place of or in terms of t. So x plus 1, x minus 1 is remaining because dx will be replaced by 2t dt, and this under root x plus 2 will be replaced by t. So let's write this x plus 1. X we have found out as t square minus 2. So just add a 1 here. This will be t square minus 1. For x minus 1 it will be what? T square minus 2, and then you subtract 1. So t square minus 3 will come. So this is t square minus 1. Denominator is t square minus 3. So 3 things we have done separately. And now we are going to combine all this. So this integration has become x plus 1 will be written as t square minus 1. The denominator x minus 1 will be written as t square minus 3. Under root x plus 2 will be t. Dx will be 2t dt. And inside an integration signature, t gets cancelled. So t square minus 1 and t square minus 3. So they both look similar. We can write t square minus 1 in terms of t square minus 3. How? If you want a negative 3, just add a negative 3 and subtract a negative 3. So t square minus 3, and the 3 minus 1 will be 2. So numerator can be written as t square minus 3 plus 2. And you can separate them in 2 parts. That is, we can form 2 different terms out of this single term. T square minus 3 in the denominator will remain the same. So this is what we are integrating. T square minus 3 differently and 2 also. But remember, this 2 will be multiplied everywhere. That is, 2 will be multiplied to the first term also, which I'll do just now. So this is integration of t. 2 is also there. I've missed writing it, but 2 is also there because 2 will be multiplied with both the terms. The second term, 2 dt divided by t square minus root 3 whole square. It is x square minus a square integration. So 2 into 1 by 2 root 2. It will give you log t minus root 3 by t plus root 3. 1 by 2a log x minus a by x plus a is the result. And since we have, as I have pointed out twice now, there is a 2 also in that integral. So we need to multiply this 2 with both the terms. So let's multiply this 2 here and 2 here. So 2 2s are 4. Now this, if you have a 4, 2 will remain. So 2 by root 3 log modulus of t minus root 3 divided by t plus root 3 plus a constant of integration. So we have included 2 twice, and there is a 2 with t also that I'll just write. So the final integration will be something like this. Let me introduce t also, 2 also with t. So 2 into what was t initially, under root x plus 2. 2 by root 3 is like this. Then we have log modulus of x plus 2 for t, x plus 2 for t in the denominator as well, minus root 3 plus root 3 plus a constant of integration. From here to here, it is the final result of this question. Now, how it needs to be written properly, this is the way you are going to go about it. So, these 3 questions were almost similar, okay? Now, this seems to be a different kind of question, but we will apply the same logic here. We need to change this under root x plus 2 or remove the under root. For that, we can have t as under root x plus 2. This t square will be x plus 2. X will become t square minus 2. Now let's differentiate both the side. 2t dt by dx, and this will become 1. So 2t dt will be dx. So dx we have got after putting t as under root x plus 2. We know what to replace for under root x plus 2, what to replace for dx. Now this x square and x minus 1 needs also some replacement in terms of t to fulfill our simplification. So x minus 1, x is already t square minus 2, just subtract a 1. So t square minus 3 can be written in place of x minus 1. What is x square in the numerator? It's t square minus 2 whole square. So we have to now replace everything in terms of t. So I will become like this. X square is t square minus 2 whole square. A minus b whole square, we will apply that formula. X minus 1 will be what? T square minus 3. Under root x plus 2 will be t only. Dx will be 2t dt. Denominator it will be t. So this t gets cancelled out. And this 2 I have taken outside. T square minus 2 whole square, as I just suggested, it will be a square plus b square minus 2ab. So t raised 4 minus 4t square plus 4 can be written like this. This 2 will use just now. So integration has become like this. T raised 4 minus 4t square plus 4. It's t raised 4, okay? There is a slight change here. 2 will be multiplied. Now the order is higher. So we need to divide this. That is t square minus 3. We have to divide t raised 4. This minus 4t square plus 4. We have to divide it with t square minus 3. So I am dividing right. This will be t square. We need a t square. For that we need a t square here. T square multiplied by t square will be t raised 4. So t raised 4 will come here. Minus 3t square. Now you can subtract these two. This gets cancelled. It will be negative t square and plus 4. Since we have negative t square, you have to multiply it with negative 1. So this will give you negative t square and plus 4. Plus 3. Now you subtract these two. So the sign will change. This first value gets cancelled and 4 minus 3 will be 1. Now how to write this? First t square minus 1 will come. Then a 1. Divided by this t square minus 3. Now everywhere 2 is already multiplied. This integration will be, let's take them as the two different terms. So we are integrating these two terms with respect to dt. So this t square minus 1 can be taken as two separate terms, integration of t square and integration of 1. So integration of t square will be t cube by 3. That is, I am doing it separately. Integration of t square dt and integration of dt. So t square plus divided by 3 will be for the first one, and then t for the second term. Now just call it as root 3 whole square here. And we can apply integration of dx divided by x square minus a square formula. So 1 by 2a log t minus root 3 by t plus root 3 formula we can apply, plus a constant of integration. Now 2 is already multiplied with all of them. So let's multiply it in order to get the final result before one step where we are going to replace t by under root x plus 2 just now. So multiply everything with 2. Now the next step will be replacement of t with under root x plus 2. So t will be written as under root x plus 2. And wherever t will come, you will write x plus 2 to the power half, because under root is to the power half only. So I'm writing the final result 2 by 3 x plus 2 to the power 3 by 2. Because it was already t cube. Then you have to put a root also, which will form half. 3 into 3 multiplied by half is 3 by 2 only. Minus twice of under root x plus 2. This is the third term, 1 by root 3 log modulus of x plus 2 minus root 3 divided by root of x plus 2 plus root 3 plus a constant of integration. This is your final result. Now how to do this? All this putting, differentiating both sides, dividing numerator and denominator has to be written by you, and the logic you have understood. Basic idea is to get under root x plus 2 change. Here also same thing. This question also just take under root x plus 1 as t square and go about the process which we learned. This we are going to take in the next discussion, and then thank you so much and have a good one.